So I want to present our first speaker for the afternoon, Laurent Picard from Paris. He works at Google Cloud, and according to his Twitter bio, he's a tech lover, passionate about software, hardware, science, and anything shaping the future. So today he's here to speak with us about building smarter solution with no expertise in machine learning. So that's a perfect role for me. And according to its last blog post on Medium, he wrote about face detection and processing in 300 lines of code. That also looks perfect for my last experiment with Raspberry Pi and my cameras. So I'm very happy to see what he has to present, and let's have him on board, and it's your time. So your screen is ready and you are on stage. So take it from there.
Perfect. Can you hear me well?
Yes, we can.
Good. Let's get started. So, hi everyone. Thanks for having me today. So my name is Laurent Picard. As you can guess, I'm French, and I'm speaking from Paris right now. My goal today is to speak about machine learning, but machine learning from a non-expert point of view. Okay. Yeah. Let me just be right here. Okay. Yeah, quickly, I've been an ebook pioneer. I've worked in the ebook business for 17 years. And for the last 4 years, I've been focusing on cloud technologies. Yeah, why am I doing this talk? It's because even as of today, after years of watching machine learning solutions, I still feel magic when I see something new done with machine learning. So my goal today is to show that any developer can develop something, including machine learning, something smart, and maybe it will feel like magic too. Okay, so this is my definition as a non-expert of what machine learning is. You have data, right? And thanks to machine learning, you can understand or you can transform your data. So you can get information out of your data, right? That's the wrong definition. The real definition for experts is that machine learning is a part of AI, right? And in particular, deep learning is maybe the field for the last 10 years where experts have developed the most impressive advances. Okay, so how does it work? Machine learning is learning from examples. At the origin, 40 years ago, the researchers, they have been trying to mimic the way our brain works or the way we think it works with neural networks. It is using many examples to build the neural networks. But the magic is that thanks to that, we are now able to solve problems that we were not able to solve before. The only issue is that we don't always know exactly how we get the answer. The answer is not always perfectly explicit, but we manage to solve problems. Okay. If we take a step back of how we can benefit from machine learning today, you can be an expert, and if you want to be an expert, then if I was in my 20s, that's what I would do 100%. You can spend your whole life working on machine learning, developing neural networks and so on. And if you want to get started, you would at least spend a few weeks and maybe months. It's endless. It's a huge, huge field. But if you have developer skills, then you can use existing machine learning models. They are available through machine learning APIs. And if it doesn't work, there's a new field called AutoML. And with AutoML, you are able to build your own machine learning model and still without any expertise. So in this talk, there's a lot of content. So maybe I will go a bit quickly and I will skip quite a few slides also. But my goal is to show you these building blocks so that maybe it will give you ideas to solve your own problems thanks to these building blocks. Okay. So first, let's get started with machine learning APIs. The input, if you remember my definition, the input can be text, pictures, videos, or speech. And you remember the information that you get, thanks to that, is understanding the input and sometimes transcribing your input into something else. Okay. I love to start with the Vision API. So it's an API by Google Cloud, but most cloud providers provide something equivalent. What I'm going to show you is all the principles. So most of the time, all the principles are the same. So what can we do with a current state-of-the-art vision model? If you give it a picture, it will describe it to you with labels, right? So this picture is about nature, flower, perfect. So this is the JSON response that I can get from this picture. Okay. Then more precisely, and here I have changed the picture on purpose. It's in New Zealand, and the vision model here is able to match this picture with another one completely different. It looks similar, but it's different. And here it's able to tell me where this picture was taken from, very close by. So it's in New Zealand where the Lord of the Rings movie was shot. Okay. More precisely, it's able to give you the bounding boxes of objects in a picture. So here, this is the cast of the movies in a restaurant, most probably, and I get all the bounding boxes of the persons, even the clothes, the pants, the tops, and even persons in the background. Okay. Even more precisely, if there are faces, then you will know if there are faces, and you will get the location of the face features, the nose, the mouth, and everything, with the different zoom levels. And also, a vision model is able to recognize generic emotions. So here, what I get is that this face is likely angry, and that's Gollum. Gollum is always angry. You even get some more features like the position of the head in 3D, whether it's blurred or whether the face is wearing something like a hat. A vision model is also now able to recognize text. So this is a big field called OCR, optical character recognition. And now, thanks to machine learning, this is a perfectly solved problem. So here, this is a screenshot. And if I give it to the vision model, what I get is blocks of text, sentences, words, and even symbols. And what's great here now, it's a almost perfect model. There are no mistakes. So it's really interesting also to see the limit of existing models. So what I've done here is that I have put a perspective effect on the picture, on the screenshot, and it still works perfectly. So now recognizing typewritten text is really a solved problem. More difficult, handwriting. So this is a letter, a piece of paper from Tolkien himself. And here the vision model is able to recognize Tolkien's handwriting too. So it's not as perfect, but it works great already. Here, ideally, I would have preferred to recognize maybe the two or one single block altogether, but it's only making two mistakes, maybe here, and here shadows is misdetected here. But it's almost perfect. And it is a very, very hard problem, a lot harder than typewritten text, right? So it works on handwriting. What would be the limit today? It would be maybe prescriptions from doctors, right? They can't even read themselves back. So, and finally, if you give input a picture with something or someone famous, it's able to match it, to match the detected entities. So that's called web entity detection. And here it's a very rare picture from a newspaper, a Spanish newspaper. It has been used only once in the world. And from this picture, I modified it on purpose. So I zoomed in, cropped it, changed the colors. It's able to tell me that this picture is about Tolkien, J.R.R. Tolkien. which is great. What I get also is an ID, an identifier for Tolkien. And here it tells me that this picture, this modified picture, matches another one. And this is the real location from the Spanish newspaper. So it's pretty amazing that it's able to match famous entities. To be famous, to simplify, you need to have a Wikipedia page, right? And so this is an API that you can call with a web request, or if it's embedded, you can call it in your own ecosystem. But you can also use client libraries. They are open source. And here, this is an example in Python, but I guess you will find one of your favorite languages. And it's always the same principle. You create a client that will talk with the API. You provide the content, so an image, and then you call the feature you're interested in, like face detection here. And then you get the results right away. So in these few lines, we are able to know whether there are faces in a picture with the location and everything, the sentiment, the position of faces, of nose, mouth, and everything. Okay. Now we've seen what you can do with pictures. You can extrapolate that to videos. It's almost the same, but with an additional dimension that is time. And if I go back here, so in a video, you're going to be able to detect objects like here, but you're going to be able to track them to know how they're moving. Like if this person is moving in a video, then you will follow the person. Okay. And for all models, if you are able to understand what is in your input, it means you can index it. So here, this is a screenshot because I don't have the time to show you the demo, but it means that we can input a video and index the video with labels. And here I can know that in this video, there is a polar bear here in this location. Okay, so it means you can maybe index hundreds of hours of videos that you have and look and find content that you had forgotten. Okay. Once again, so I've written a few code labs, a few tutorials. Here, this is the way to call the Video Intelligence API with a few lines. You create a client. You say, for instance, you're interested in object tracking. You specify if you want the whole video or just some segments, and you call annotate video. You wait a little bit more, so it's not in a 1 second this time. It depends on the duration of your video. But once you've done that, then you can know if you have objects in your video and you can track them. So if you want to know how it's been done, there's a tutorial. And you can also follow me on Twitter. I have a GitHub repo where I've shown how I did that. How you can just put videos in a bucket in the cloud, and then it will automatically detect the objects inside. Then on to text. So machine learning also is a revolution for text, because the first research to understand input were on text. It's also a big field called NLP, natural language processing. And there are natural language models. And we do have the natural language API. So this time, the input is text. It's able to tell you which language it is written in, the syntax of your sentences, is the verb, the noun, everything. One interesting feature is that you can ask for lemmas and get the canonical form of your entities. So like here, was is the verb to be. So you can simplify if you're looking for some verbs or nouns. Okay. On the same piece of text, I can ask for entity detection. And here I get 3 different groups. In red, we have persons. Tolkien is a person. And one thing that amazed me is here, you see I get an ID about this entity, and it is exactly the same ID as before when I had a picture of Tolkien. So Tolkien was not written anywhere in the picture. Tolkien was detected recognizing the picture, and it's able to tell me that here we are talking about the same person. I have the same ID, so I can identify entities the same way in text and in pictures or in videos. And that is pretty amazing. Sorry, I have, okay, coming back. Then British is mapped to a location related to the United Kingdom. And finally, at the end, the three books are each recognized as works of art, which is also perfectly correct. And then finally, on text, you can ask for classification. And this small piece of text should be classified under books and literature at 97% of confidence. That's perfect. To give you an idea, the New York Times is using this API to classify, automatically classify very old articles that they have scanned from paper when computers were not available. Okay, so it means you can really understand what is in any text. And finally, like in pictures, a natural language model is able to recognize sentiment in sentences or in full corpuses of text. So here, for this example, I've taken two reviews of The Hobbit, one positive from the New York Times, a very old article, and this one from The Hobbit in a social network about book lovers. And the second one is pretty negative. And it does work. For each sentence or each block of text, I get a score, a rating between -1 and +1. And here, these sentences come from Pauline's review. Pauline hated the book, so it shows. Of course, you get many neutral sentences. Most of the time, we are neutral. And here, as you can see, this sentence, very positive sentences, come from the New York Times review. So it means you can understand from text, for instance, how we are talking about your company, about your products. Companies are using that to browse, to retrieve tweets or web pages, anything, or to analyze emails from customers. And it's especially interesting to know when we are talking negatively about your product, because it means maybe you have a bug, maybe you have to react quickly, maybe you have to communicate with your customers to reassure them. Some companies are using that to treat emails, negative emails, in priority. So thanks to this kind of analysis, you can be a lot more efficient, so smarter. As you can see with the client library, just a few lines still. So you provide the content, can be text or HTML, and you call analyze sentiment, for instance, and then you have the results very quickly that you can parse and use here. Once again, I've written a code lab if you want to get into the details and try it in a Cloud Shell. Okay, and about text, another one that is now not perfectly, but very impressively well solved thanks to machine learning. That's, you have all tried it one day, I would bet. This is a Google Translate. So Google Translate is actually the translation API underneath. And it's able to translate from over 100 languages to over 100 languages, thousands of different combinations. Here, my code sample is terrible because I have only 2 lines of text. I have more comments than everything else. You create a client, you call translate, and that's it. You have seen the translation working in a browser, pretty sure, with the live translation on web pages. I can share something with you. In 4 years ago, so in 2016, I was not working with Google. I had my own company before, and I was using Google Translate. And one day I noticed that the results were a lot better. And I learned later, so since I joined Google, that what happened at the time is that Google switched from a statistical model to a machine learning model. And the quality jump was very, very high. And since then, it just kept improving. constantly. Because what's cool with a machine learning model is that you provide more examples and it is learning even more. You provide counter examples if something is wrong, and then it will correct the mistakes. So the translation now is pretty impressive. It's not fully solved, but it's at a very, very high level. Now, next is a speech. So you can transcribe speech to text and text to speech. I will go very quickly. That is the basis of assistance. I'm sure you have one on your smartphone. So if you're able to transcribe speech to text, it means you can index it, right? And once you have the text, it means you can understand what's in your text with the natural language API. So that's how an assistant works today. Transcribes speech to text, analyzes the text with the natural language API, and then gives you an answer with the text to speech. So yeah, so you will see. I will give you a link at the end for the slides, so don't worry about it. If you're interested, the way speech is generated is thanks to a DeepMind model. It's called Wavenet, and it's able to generate, in 1 second, it's able to generate 20 seconds of speech. And the speech, I have to admit, I'm a bit jealous because I love the vision, the way we can solve vision problems. But I have to admit that this model, the Wavenet model, is the most advanced of all the machine learning models I have seen, because it's able to generate a voice that is very, very human-like. That's the voice you have on Google Homes, for instance. It's very, very natural, and you don't think about it. So this is the proof that it's working very well. Maybe let me show you a demo quickly, if that works. Okay, so I am, okay, let's go on the English page, and I will try to speak with a French accent. What is the temperature in Paris? So I hope you could see, but it was able to transcribe my speech in real time. So when I started to say temperature, it understood something else because it only had the beginning of the word. But at the end, the transcription is perfect. And you couldn't hear it, but I got the answer spoken with a Wavenet voice. So that works in the Chrome browser. It's using these APIs. Okay. So once again, I've written a code lab if you're interested how you can generate speeches with different accents. There are, I think, over 100 different languages now. So the next step, I'm going, a couple of minutes more. AutoML. So let me give you an example. Why is AutoML useful? So if you remember the Vision API, if you give these two pictures to the Vision API, you will get the same results. So because basically those pictures are skies, are clouds in the sky, right? So it's almost the same answer. But if I want to understand and be more precise and understand that here there are cyruses and here altochemulses, for instance, to make weather forecasting, then I'm stuck. And here AutoML is here to help. So the way it works is this time you need to work a little bit more. You need to create a data set with examples. So it can be pictures, videos, text, structured data. You create the data set with the examples and you give the answer that you're expecting. And then you launch a training. Often you do that a couple of times, or at least 1 or 2 times. And then at the end, once you've done that, you launch a training and you have your own API, your own private API. And you can call it in batch mode if you have lots of data that you want to process, or if you want to make live predictions, then you can you can deploy your own API. It's yours. And then you can do exactly like we've done before, but it will give you predictions for your own needs. You can also create an edge model that you can export to a Raspberry Pi, into a Docker container, or also in a web page. So I've written let's go on. Okay, so here for the clouds, the cloud example, what you need is, for instance, lots of different pictures. You label them. You don't need millions of pictures like for state-of-the-art models. You just need a couple of hundreds pictures. And then you launch the training. So here are two examples, a 1 hour training and a 3 hour training. Then once you have your training is done, you can evaluate how well it's doing. So here it's doing great, except for the AutoML. So maybe I don't have enough pictures, or maybe they all look like the same. And then you have your own API, and you can upload, or you can input new pictures it has never seen, and then you will get predictions. And here, this is a picture of mine from Poland, and at 97%, there's a cumulus, and that's perfectly correct. So as I told you at the beginning, it works on text, images, videos, and structured data. And you can get custom classification, custom object detection, custom translation. So you can build from this your own machine learning models. So I've done a small demo. I hope we can all do it together. Let's take 2 minutes for that. We're going to try to detect generic emotions and custom emotions with the Vision API and with my own model. So I've been taking pictures of me and my teammates with the tongue out, yawning and sleeping. And let's see how it works. So I don't have the time to explain exactly how it works. I invite you to get connected on with this QR code, or you can also type this URL, bit.ly/mlcloudconf20. Okay, and you should reach, I give you one more moment, you should reach this page. Okay, you authorize the webcam, and let's get started. You can try try to be happy. Hey. If you didn't get the QR code, I'm giving it to you again, okay? So, yeah, as I don't see you, it's a bit hard, but okay. And so I am joyful. As I'm able to detect the nose and the mouth, then I can add a mustache to everyone, okay? Let's try now my own AutoML model. So if you click next, and now you can try to stick out your tongue to yawn or to sleep. So this time the mustache should have the Italian flag colors, and it does work. So of course I've been cheating here because I trained the model with pictures of mine. So it's normal that it's able to recognize somehow my mouth and my tongue. Okay, but hopefully if you could do the demo, we are going to see. Yeah, I couldn't see you, so I didn't know if there were some of you. So happy people, great. No one surprised, no one sad, no one hungry, but we do have a few people. Great, 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 with the tongue out. So you see, it does work. Yawning, sleeping. And if you remember, we can do object detection. So here we have folks with stashes and classes. So you see, it's really, really easy to do. I don't have much time, so I'm going to maybe skip a few things. So you see that works very well. It took me 2 days to build the data set, 2 days only. If you want to evaluate, you've heard these words, true positive, false positive, and likewise the false and true negatives. So keep that in mind. If you want to evaluate how well your model is doing, you will get this kind of statistics or information when you've done your model. So here I'm skipping a lot of slides. You will find them online at the end. So let's recap. How can you build smarter solutions? With ML APIs, you just need hours. So to the first demo I've done to detect faces, it took me a couple of hours. So in one afternoon, that's it. You're done. For AutoML, I told you it took me 2 days. If you want to become an expert, it's at least weeks and maybe months or years. The difficulty with the API, you just need to be a developer and make an API call. So that's very easy. For AutoML, the richness is coming from your dataset. So you need to work on your dataset, I would say, for a couple of days, and that's it. You will train the state-of-the-art model, and it will predict and give you great predictions. So those are resources if you're interested about the APIs, AutoML, and TensorFlow, which is the most favorite open source machine learning repo on GitHub. It has become a standard now. Here is a comic about machine learning. If you'd like to refresh your memory, and you will learn a lot more terms. So start to become an expert. But it's a very nice comic. Done by Google AI. And here are my slides. And if you'd like to send me feedback also, you are very much welcome. You can follow me on Twitter, on Medium, and other places. You will find articles, you will find source code on GitHub. So my goal today was to give you a quick overview. It's a lot of stuff. You can do a lot, and you can integrate this into your own solutions and make them smarter. So I hope it gave you ideas. I hope you will now make your solutions smarter and maybe solve your own problems. Thanks a lot for having me today, and see you next time. Bye-bye. Maybe questions.
Thank you, Laurent, for your presentation. It was great. I always love the machine learning one because they are so interactive, and there is always the wow effect for them. So thank you for that. We actually don't have any question, but if you have any, just share them on the chat. I'm sure Laurent will be happy to answer them. But I read very good feedback about your presentation in chat. So thank you for coming, and thank you for sharing your knowledge with us today.
Thanks a lot, everyone. Take care. Bye-bye.